Hey there, physiology students. Here we go. Essential question 2. How does the muscular system interact with the skeletal system? We actually, as I mentioned at the end of last class, we sort of threw in the joints in this unit instead of the skeletal system because they actually work more in conjunction with the muscular system in the sense of, you worked with a little bit with the agonist and the antagonist, and that has a little bit to do with it. So we're going to look at the joints as well. So you will need to know, be able to identify the joints. So what are joints? And they're all listed on pages 165 through 167. They are junction between bones, made up of the connective tissue, which you learned back in the first unit. There are three classifications. We have fibrous joints, we have cartilaginous joints, and we have synovial joints. So those are the three that we're going to be talk about the most. Well, the fibrous joints are the ones that you can find between the skull plates, right? As you learned about the bones last unit, about the between the separation of, let's say, the temporal and the parietal and the frontal and the occipital. We do have sutures of joints or connections, and these are immovable, right? Obviously, sort of makes sense, right? So it's a thin layer of dense connective tissue which joins bones together. So in this these flat bones within the skull. So there's an example of fibrous. Cartilaginous, those are within the vertebrae, okay? Limited movement, mostly rotation, bending, so very limited movement. And you can see we have this fibrocartilage between each of the joints, and that allows for that cushioning and movement of the joints. All right, so those are the two, so fibrous and cartilaginous. The most common is the synovial. These are the free moving joints. And that's usually what so we have a few different types of joints. So the most common ball and socket, our hip, our shoulder. That is, where you have the actual ball and a socket, right? And they rotate around. Condylar joint. So these would be the joints where you crack your knuckles. Those are the they're flat joints, allows for movement, obviously, and then so those would be found in the foot and the hands. The plane would be more of so these would be the metacarpals and the phalanges. These would be more in the carpals and the tarsals, all right, where there's not a lot of movement. There is some movement, but for the most part, they're just, we have so many bones in our hand and our feet that we didn't even name. So there are separations between them. There are, cartilage between them. And so those are still what we call a plane joint. And you can sort of see, where that is. The hinge joint, elbow and knee, I sort of, pretty basic, right? Just works on the hinge. Pivot joint. So this is the axis of your skull. The top one that allows you to rotate your head, and then the saddle is your thumb, and that allows for the rotation of the thumb, the imposable aspect of it. That's what we call a saddle joint, and these are pretty much named from the way that they work, right? So this sort of looks like a saddle, but that's where they get the name from. All right, so those are the synovial joints. Okay, so remember that the synovial are free moving, cartilaginous are slightly movable, right? Not a lot of movement. Think of your vertebrae. You can't really move it quite, as much, but you still can. And then your fibrous joints are non-movable, right? Those are within your skull. So those are the three types that we talked about. All right, so how do they work together? Well, we're all familiar with ligaments and tendons. And so ligaments are bone to bone, right? So if you think of the most common would be your anterior cruciate ligament, right? The one that gets torn a lot. Follow the 49ers. We lost a couple players due to that on that turf, where it sort of keeps the bone to bone. There's really no muscle holding the knee together in a sense. We just have we have meniscus and we have ligaments within our knee. We don't have really any tendons, although, where the calf joins to the muscle up to the femur, that will be part of it, but that's, for the most part. We do have a tendon on our patella, a patellar tendon, so that would attach the kneecap to your anterior cruciate, and we have one above that connects it to your quadricep. So we do have a couple tendons, which are muscle to bone. The most common, Achilles, where you have your calf muscle, your gastrocnemius attached to and your soleus attached to your foot. All right, so that would be the most common, if you think about ligaments versus tendons. Let's see, levers. Okay, so a little bit of physics. We're not going to get too much into it. Don't worry, there's no math. We just sort of have to, this is the type of system that it works off of. Bones and muscles interact like levers. So, you have, if you did take physics, you have a rigid bar, which would be your bone. The fulcrum or pivot point would be the joint. The weight, so that would be the object that moves against the resistance, and the force that supplies energy for movement would be the muscle. So those are the basic body parts when we're talking about how does, lifting a weight, we need you to identify what these particular aspects are, what bone is involved, what's the pivot point, what joint would be involved, what's the object moved against, obviously the weight, but then what muscle would be involved in that movement. So sort of working together. So you should know the muscle, bone, and joint. If, let's say you're lifting a weight, and we have a couple of examples, right? You have your resistance, you can't really, so here's your fulcrum down here. I don't know if it's shown here. So this would be your fulcrum. This would be, your force, your resistance, your force, and your rod right down here, right? So, and then we have different types of, you remember the first class, second class, and third class levers. We have all those different types, right? Where you have the force here, resistance, and so on and so forth. But don't worry, we're not really gonna, so, here's the resistance, here's your fulcrum on your toes, and your force is your calf muscle, and the resistance would be the weight, right? So we have all these different types of, you can Google it. Okay, so muscle movement. We have origin and insertion. So origin would be the immovable end of the muscle. Insertion would be the movable end of the muscle. So for instance, if you're doing a bicep curl, the origin would be up near your shoulder. And then the insertion would be down by, in your lower arm, in your arm in here, right? So when a muscle contracts, the insertion is pulled towards the origin, right? And that sort of makes sense. So when you contract, the movement is towards the origin and away from the insertion. Okay, flexor versus extensor. Decreases the angle during movement. So for instance, if you're doing a leg curl, like a hamstring curl, that would be your flexor, and then the extension would be, extending it out, right? As they show, right? So that would be, flexor would be decreasing the angle, extensor increasing. So tricep is an extensor, your hamstrings are extensor, those types of thing, right? Where it has the decreasing the angle, or increasing the angle, I'm sorry. Interaction with skeletal movement, again, we maybe should have talked about this before you did your lab, but I think a lot of you could figure it out, or at least if you asked me. We have agonist versus antagonist and the synergist, right? So the agonist is the primary mover. The muscle provides the most movement. The antagonist is the one that resists the prime movement. So, you know, if you're doing a bicep curl, you got your tricep. The synergists are the muscles that assist the prime mover. And that's sort of, you know, if you think about doing free weights as opposed to, let's say, a machine weight. So you're not really using your synergists so much in the machine weight because a lot of that guidance is done for you. Where if you're doing, let's say, a dumbbell exercise, you're incorporating a lot of those synergists to help stabilize and to help that prime mover. So sort of the, you know, the benefits would be with the machine, you could sort of isolate that muscle a little bit more, but at the same time, you do want to increase the strength of the synergists as well. That's it. And here's just some examples of agonists and antagonists. All right, so again, some of these should be, so this is iliopsoas, the P is, so this is your hip extension, the iliopsoas is in the front of your hip, obviously, the gluteus maximus is your butt muscle. Trapezius is your traps, if you know, the latissimus dorsi. So just some, you know, I think most of these you should be familiar with. Some of these are smaller muscles. The iliacus is a smaller muscle, you know, more, and then you have your adductor and you have an abductor as well. And this is gluteus medius and psoas, right? So just some names that you should maybe get comfortable with, and we love this name, the sternocleidomastoid. So you have your sternum and your mastoid muscle, so that's sort of or your mastoid, your bone. Anyway, all right. So that's it for those notes. We will have a quiz on these. So go ahead and interact with them, and that should be it.